Good evening, sir.
Good evening, sir.
Good evening, everyone. What is the near point of a normal human eye? Anyone?
25 centimeters.
25 centimeters.
25.
So it is the nearest point at which a small object is visible distinctly. (25 to 30 centimeters). And it varies with the age of the person. For numerical problems, its value is taken as 25 centimeters. Okay. Clear?
Yes, sir.
And then there is a far point also. What is the far point?
Farthest distance at which a small object is seen distinctly.
Yes. The position up to which, or the farthest point that is visible. When fully relaxed. And it is infinity in case of normal vision. But the person who has some defect, these near and far points, they may be different. Either both or one of them will be different. Okay. Clear?
Sir, infinite तक कैसे देख सकते?
Please speak again.
Sir, infinite तक कैसे देख सकते?
Infinite तक, have you ever traveled in a bus?
Yes, sir.
Or you might have traveled in a train, obviously.
Yes, sir.
So when you travel in a bus or train, so sometimes when you look at far away place, there are a lot of trees, and then you see that you can even look at the object that is farther away. Have you noticed this?
Yes, sir. Yes.
And that distance is quite large. Okay, so if there is plenty of empty space in front of your eye, so then that distance is quite large.
Yes, sir.
Let me give you another example. Can you see the moon?
Yes, sir.
So what is the distance between moon and
Okay, sir. Okay, sir. Okay.
Clear now?
Clear, clear.
So that's why it is taken as infinity. And some stars are further apart as compared to the moon even.
Yes, sir. Yes.
So defects of vision, obviously, and their corrections. Now for the normal eye, the image of the objects, they are sharply focused on the retina.
Yes, sir.
Okay. Means whether the object it lies near to the eye or away from the eye. Okay. So it is done automatically by the eye. Actually, the eye lens, it can change its focal length by changing the thickness. Okay. So the eye which fails to do this, that is, which does not possess the power of accommodation. This is called power of accommodation to adjust its focal length, is called a defective eye. Now there are various kinds of defect that we can associate with eye, and 4 common defects. Long-sightedness or hypermetropia, short-sightedness or myopia, presbyopia, astigmatism. So these are the 4 defects. And now let us discuss them one by one.
Yes, sir.
No, sir.
So it is other way around. Long sightedness means they can see the far away objects, but they cannot see the nearby objects. Short means they can see the nearby objects, but they cannot see the far away objects.
Yes, sir. उल्टा होता है ना?
Okay. For a normal eye, this is means it may be 30, 35, 40, depending upon the defect. Okay. And let me show you with the help of diagram. Let me make the diagram on the next slide. First of all, let me tell you about the causes. Eyeball becomes smaller. That means the distance of retina from the eye lens decreases. Of course, with the age or some kind of injury. Or second is the focal length of the crystalline lens is large. Means power is small, na? So it cannot converge the rays at retina, rather at a point away from retina. This is the eye lens. This is the normal near point, but due to the defect, the rays they do not meet at retina, rather at a point away from retina. Okay, this was 25 centimeter only, normal near point. Okay.
तो सर इसके लिए हमें कॉन्वेक्स लेंस की जरूरत पड़ेगी ना?
Yes, yes, definitely. So this can be corrected by using okay. Clear? Clear?
Yes, sir.
So then the person becomes capable of reading the newspaper, book, and he can see he or she can see the nearby objects clearly.
Excuse me, sir.
Yes.
Previous slide, please.
Done, sir.
When we close our eyelid a little bit, then our eye lens it draws closer to the retina, and that way we are able to see the far away objects. Okay, the person who is suffering from myopia, then he or she can see the far away objects. But with complete eyelid open, they cannot. And why this happens? Because the eyeball is long this time. The elongation of eyeball. Distance of retina from the eye lens increases. Okay. And the second reason is focal length of the lens is small. Power is large, so the image is formed in front of the retina rather than being at the retina. It is in front of the retina.
Yes, sir, तो इसमें कॉन्केव लेंस लगाना पड़ेगा.
Yes. Please check. Clear?
Yes, sir.
Yes, sir. Yes, sir.
Presbyopia. What is this defect? And why this happens? Because the muscles of the eye they become weak with aging, and hence the power of accommodation of eye lens it decreases. Okay, so this defect it increases with aging. Ciliary muscles of our eye. and diminishing flexibility. Bifocal. Bifocal means something like this. This lens is different and this lens is different. Okay. Please note down. Clear?
Yes, sir.
Last one is astigmatism. In this kind of defect, the person cannot focus on horizontal and vertical lines simultaneously. Means those lines, they appear to be curved. The straight lines, they appear to be curved to a person who is suffering from this defect. Or you can write horizontal and vertical lines simply. For as an example, we can take the wire gauge. I will. Okay. Actually, I will have to take the help of software then, because first of all, I have to draw the straight lines. Means actually the lines are like this, but the person who is suffering from this defect, he or she will see the lines like this, or either like this. 1 minute. Okay. This is the normal wire gauge. Clear?
Yes, sir. Matlab one of them seems to be different.
Yes, simultaneously cannot focus. Huh? So when he's focusing on vertical lines, if they appear to be straight, then the horizontal they will not. And if the horizontal they appear to be straight, then the verticals they are not. Okay. And what is the cause? What is the cause? When the eyeball is not perfectly spherical, or you can say the cornea. Different curvatures for and hence due to this are well focused and the objects in the perpendicular direction they are ill focused or not well focused.
सर प्रीवियस स्लाइड सर बहुत जल्दी लिखा रहे सर आज
Fast है?
Yes, sir. बहुत fast चल रहा है.
Okay, you can tell me. I can be slower than this. Done?
Yes, sir.
क्लियर सर
And this defect, it can be corrected by using cylindrical lenses. And these cylindrical lenses irregularities in the curvature of the cornea.
Yes, sir.
Let us discuss some numerical problems. First one, a person with normal near point reads a book using magnifying glass. What is the closest and no? See, this one. Actually, these are for magnifying glass. Means magnifying, if the magnifying glass forms the image of the book at these positions, within these positions, only then the normal eye can read the book. Na? Have you understood? Means the nearest point at which the magnifying glass can form the image of the book is at 25 centimeter. Okay.
Yes, sir.
And the max is infinity, of course. Here.
So can you please repeat?
For the normal eye, these are the near and far points. Na?
Yes, sir.
So when you have placed the magnifying glass between the book and your eyes, it means the magnifying glass, it is forming the book image of the book either at a minimum distance of 25 centimeter or at a maximum distance of infinity. Na?
Yes, okay, I got it.
So now we have to find u, means where we can place the book. Okay, so that it can be read clearly with the help of magnifying glass. Clear? So
Yes, sir.
So now substitute the values. Focal length is 5 centimeter and V is also known. So try to get the value of u. So when we have to find u minimum, this should be maximum and this can be maximum when V is minimum. Let me write on the next slide. Number 1. Minimum So means you can adjust the distance of the book from the magnifying glass between these two values. Means there is a margin of 0.83 centimeter.
Yes, sir.
Done, everyone?
Yes, sir.
Some conceptual questions are there. Please check. Yes, Durga. It means the corrective lens will form the image at 80 centimeter in front of the eye. Na? So for the corrective lens, this will be V, na? And U will be infinity, of course, because the object lies at the far point of the eye. Okay? Clear or not?
Yes, sir.
We are finding the focal length of the corrective lens, na? And it is given that the far point is 80 centimeter. Means the person can see the objects from 80 centimeter and not beyond that. So what the corrective lens will do, it will form the image of the object lying at infinity at 80 centimeter in front of the eye. Na? So it means U is minus infinity and V is minus 80, na? For the corrective lens. And that way we are able to find the focal length and hence the power. Therefore, the person please check.
Sir, 100 by minus 80, na?
80, sorry, I wrote 8 only.
Yes, sir.
So now in the second part, in what way does the corrective lens help? Obviously, does the lens magnify very distant objects? First of all, we will write the corrective lens will form the image of the object lying at infinity at a distance of 80 centimeter in front of the eye. In front of the lens, front of the eye. Yes. The question was, does the lens magnify? No, the lens does not magnify. In fact, it reduces the size of the object. then why the eye is able to see the object at infinity now? Because now the lens is forming the virtual image of the object lying at infinity at a point 80 centimeter in front of the eye. Okay. Clear? And now the person prefers to remove his spectacles while reading a book. Why? Because the book is lying at the near point now. And for a myopic person, the near point is okay. There is a problem with the far point only. Isn't it?
Yes, sir.
A myopic person uses concave lens. So a person wearing spectacles using concave lens, which use concave lens. Please note down. Then I will explain on the next slide.
Yes, sir.
Okay. So that is the reason he prefers to remove the spectacles, because that way he has to push the book further apart from the lens, because he is wearing a concave lens, which diverges.
So it seems it's very big to it. Strain his eyes.
He cannot see because of the strain on the eye.
Yes, sir.
Because it will you can say diverge the rays too much, so that the image is not formed at the retina, you can see. But when you push the book a little bit forward, then he can see. So that's why he prefers to remove it. Otherwise, there will be a strain on the hand also, because he has to hold the book like this. Okay. ऐसे पकड़ेगा ना वो, दूर थोड़ा.
Yes, sir. Yes, sir.
Clear?
Yes, sir. Yeah.
So another one similar to this, but now with another defect. Similar question. Not right. So what should the corrective lens do in this case?
Object distance is 25 centimeters, so it must form that image at 75 centimeters.
Yes. So it will form the image of the object lying at 25 centimeter at a distance 75 centimeter from the eye. Means again U and V both are negative, because 75 centimeter it is in front of the eye, na? And 25 centimeter also. Okay. How much? A little bit less than 3, no? 2 point. Please note down.
So 2.67 diopter.
Oh, sorry. Done. So what the lens is doing? Now we have to write that part for the second case now. Yes.
Yes.
The corrective lens forms a virtual image at 75 centimeter in front of eye of an object at 25 centimeter. Okay. So the sub part is, does the lens magnify objects? Now who will tell me?
It will magnify it because f के नीचे f से कम है ना ऑब्जेक्ट से magnify तो होगा.
Magnify कैसे?
तो convex lens है ना, तो
No, it is not magnifying actually. What we have written in this line, actually, this is the answer.
25 पे 75 हो जाएगा.
25 से 75.
हाँ.
75 से 25 हो गया. 75 तो पहले था.
तो magnify नहीं हुआ, कम हो गया.
The near point was 75. ना? So now the lens is making the near point to be 25. Image मत देखिए, आप correction को देखिए. Are you getting me?
Yes sir.
Correction
B equal
को
25 और B equal 20.
It's correcting the near point of the person. Na? So the person is having the near point to be 75 centimeter. But now he's able to see the objects lying at 25 centimeter. Means the lens is making the near point from 75 centimeter to 25. Na? ये कर रहा है lens. So lens does not magnify. ये सिर्फ either it is bringing the object nearer or दूर कर रहा है. ऐसे दोनों cases में. Does not magnify. Sorry, magnify the object. Okay, but brings the object to the near point of the hypermetropic person, or you can see eye. Okay. Now what is the third one? While looking at the sky, he prefers to remove the spectacles. Why? Explain. Again the same reason.
Far point is intact for that person, so he prefers it off.
Metric eye has far point at infinity. There is no problem with the far away objects. No? Okay.
Yes.
Now wearing spectacles with converging lens. Will converge the rays coming from infinity more than that is required. Okay, so hence the person prefers not to use the spectacles while looking at the sky. Is it okay?
Yes.
Done, everyone.
Yes, sir.
एक्सक्यूज मी सर.
Yes.
सर जो प्रीवियस स्लाइड का लास्ट सेंटेंस का हिंदी में एक बार बताइए ना, लास्ट सेंटेंस.
Let me tell you with the, actually I cannot insert the slide right now. Wait.
ओके सर.
मैं slide एक slide insert करके आपको with the help of diagram आपको. Let me insert the slide in between. Are you able to see the screen now?
Yes, sir.
Now see, if suppose the object is lying here, just for the reference. Otherwise, the sky is at infinity. Na? Here is the eye. Here is the eye. Okay. So the eye is having the power to accommodate the rays that is coming parallel. This is without spectacle. Okay.
Yes, sir.
So the image is well formed at the retina. But now the person is wearing the convex lens. Na? Am I right?
Yes, sir.
So if you place the convex lens here, what will happen? This will converge the rays
Yes.
रेटिना के पहले ही बन जाएगा.
This will again converge the rays. Now where are you getting the image?
So retina के पहले ही.
So फिर will it be possible for him to see the object in such a situation?
No sir.
So that's why he prefers to remove this spectacle,
Yes sir. Now clear.
because the far point is correct for this kind of eye. Only the near point is problematic. Okay.
Yes sir. Now clear. Thank you. Sir.
Means he do not require any kind of spectacle for looking at the far away objects.
Yes sir.
This is number 19. Okay. Yes. Means the near point is problematic, na?
Yes sir.
So what is U? Minus 40. V is minus 100. Na? Near point is 1 meter for this person, na? But
Yes,
he wants to become able to read from a distance of 40 centimeter. Means that is U. And now we have to find the focal length of the power of the lens, na? That is required for
Yes,
this purpose. So focal length nikal ke you can find the power. Na?
Sir, 1.5 diopter.
Yes. No need, na? 1.5 is 100 by F. So power is 1.5 by F. No need to find F because we have to find power, and that is coming directly. Na? Please check. Clear?
Yes sir.
So just a minute. Yes, sir.
So power is given, you can find the focal length first. $50 cm, or rather you can write plus 50. To read a book at 25 cm. So now you can find the near point. No?
minus 50.
Okay, you're telling me the answer. Okay, so therefore, okay.
Yes sir.
Clear?
Yes sir.
So now you can practice problems related to this part. So we will end our discussion here, and tomorrow we will discuss some more numerical problems, some MCQ type and PYQs, and then I will discuss with you some PYQs related to interference and diffraction. Okay, students. Bye bye.
Thank you, sir.
Thank you sir.
Thank you. Thank you, sir.